Bismillah ar-Rahman ar-Rahim wa salatu wa salam ala Rasulullah Muhammad bin Abdullah wa ala alihi wa ashabihi wa mawala wa ba'd. Good evening, my listeners, my viewers and my subscribers. Today on Swap Academic online class, I'm going to be taking you stoichiometry aspects in chemistry. You know, we have different aspects. We have organic, we have inorganic, we have analytical, and we have so many aspects. But in today's lesson, most of the students are complaining regarding this particular topic. Let's even look in depth of what is even this topic, what this thing is entails, right? Let's see what are the things that we can see in this particular topic. What is the essence of this topic? Firstly, before we can enter anything or any calculation in this particular topic, let's quickly see what is even the definition of this particular topic. If we see the definition regarding this, then we will likely be able to solve some problems or exercise under this topic. Are we together? You call it anyhow. We are not in English class. Are we together? Now, this particular topic, which is stoichiometry, is an aspect in chemistry. This is an aspect in chemistry. This is an aspect in chemistry that has to do with the relationship with the relationship between mass and volume, between a mass and a volume. That has to do with the relationship between mass and volume. Are we in chemical reaction? In chemical reaction between mass and volume, right? In chemical reaction. Or when we mean reaction, you know what that means. Like I'm having acid reacting with base, like sodium hydroxide reacting with HCl, hydrochloric acid, to form sodium chloride and water, isn't it? So reaction between acid and base give us salt and water. Are we together? That is not. Now we want to know, assuming we have NaOH. This is sodium hydroxide. The industrial name for this, for those preparing for exam, they can ask you, what is the industrial name of this? It is It is soda lime. Soda lime. That is the industrial name for this. Those preparing for exam, soda lime. Are we together? But the chemistry name of this one is sodium hydroxide. NaOH. Are we in? Now we have, if this is NaOH plus we have HCl, right? This is a base, this is an acid. It gives us what? It gives us, match it together, which will give us NaCl plus H2O, isn't it? This is salt, this is water, this is acid, this is base. This is not what I'm really going to. But I want to explain the time stoichiometry. Now, if you want to know the numbers of moles of sodium hydroxide reacting with this to form this and this is the topic that will tell us more about that. If you want to actually know the mass, the total mass of this reacting with this and this, reacting with this to give this and this, it has to do with this. That is why they said is the relationship between the mass and the volume. Are we in together? Or it can also be referred to as the quantitative. It can also be referred to as the quantitative. As the quantitative analysis. As the quantitative quantitative analysis of determining of knowing. Let's do that. Of knowing the numbers of each, the numbers of the volume, of the mass, of the moles, of the molar mass of each element present in the chemical reaction, of knowing the numbers of each element regarding the volume, are we? Regarding the volume, the mole, the molar mass, are we together? The mole ratio, are we together? The reacting mass, etc., in the chemical reaction. In the what? The mole ratio, the reacting what? The reacting what? Masses. Are we together? The volume and all other parameters. In a what? In a chemical what? Reaction. These are the two definitions. Now the essence of doing this in chemistry, in industrial chemistry, where they do coke, the production of so many things, they have to know the numbers of water they will mix with some particular material in order to get coke. The art of knowing these numbers of one nutrient adding to another one is what we know as stoichiometry. Are we together? That is that under that. Now, since we have gotten the definition, let's see some little things in this. What are the things regarding the calculation aspect of this? Are we together? Now, in this stoichiometry, we have what we know as mole ratio. What do I call it? Mole ratio. I'll tell you what a mole ratio is. We have what we know as what? Mole ratio. Now, this is the areas of where I want you to put your fully attention. We have number 2. We have what we know as mole. Are we? Which is the mole concept. Are we together? We have what we know as number 3. I will explain that. We have what we know as coefficient. What do I call it? Coefficient of mole. Are we together? Are we in? And we have number 4. We have some other parameters like the molar mass. Are we? Molarity. I will tell you all these things. Or another name for molarity, we can call it what? Concentration. As a science student, if they ask you another name for molarity, it is called what? Concentration. And it is denoted as what? As C. Or capital what? M. In some textbook, you can see it C. In some textbook, you see it what? M. We call it what? Molarity. We are going to be seeing something on this. And so many things. So when we are going gradually, I'll be telling you what and what. Let's pick this one. Mole what? Mole ratio. Are we in? Mole ratio is when we have, we want to know the numbers of mole reacting with another mole, another element, the numbers of moles of one element reacting with another numbers of mole of one element to get another what? Another product. Am I communicating? That means, assuming we are having H2 plus what? Plus O2, what will that give? It will give us what? H2O. Are we together? In chemistry, if they ask you what will be the mole ratio, the mole ratio implies you balanced. You firstly balance the what? The chemical what? Reaction. How do we balance that? How many H is here? 2. How many H is here? 2. How many oxygen is here? How many oxygen is here? 1. Are we together? Now you find a mix. That means oxygen is the one that we have to what? Balance, isn't it? By what are we? You put what there? You can put 2 here. Everything becomes balanced. But it has affected this one, right? This is coming, the hydrogen here becomes what? 4, right? Put what here? 2 here. Is everything balanced? It's balanced. Now, let's relate this with this. We want to know the mole ratio. Now, you will check. What is this is hydrogen what? Gas, isn't it? What is the coefficient that is at the front of this hydrogen gas? 2. What of this one? What of this one? In chemistry, that's what we call mole ratio. That's what we call what? Mole ratio. we have 2, ratio what? 1, ratio what? 2. In physics, chemistry practical, we are asked to make use of this mole ratio, where you will be dealing with CaVa equals to what? Cb, V what? Vb. All upon what? Na, Nd. Am I communicating? So, guys, where they get Na over what? Mb. These numbers of mole is still the same thing as mole what? Mole ratio. Numbers of mole of acid. Numbers of mole of what? Base. Are we together? That's this where they get something of that. But we are not dealing with acid here or base. That's why I'm not using AN something. So here we have what? 2. Here we have what? 1. Here we have what? 2. That is the mole ratio. The mole ratio for this particular reaction. It is what? 2 ratio 1 ratio what? Ratio 2. Are we in together? Now I mentioned coefficient of what? Of the reaction. Coefficient of the mole ratio. The coefficient is still the same thing as 2. This is 2. What is this? 1. What is this? 2. Are we in together? Now another thing I want you to know. Now if you want to calculate, maybe you are given a question regarding this stoichiometry, and we are given that we are going to set one question now. We are given that this particular aspect, hydrogen gas, should be 2.0 mole. Should be what? 2.0 mole. We are going to set a question. Are we together? And we are given what? We have to find what? The moles. Find the what? The moles. Moles of what? Of what? O. Oxygen gas that will react with this. That's what we call stoichiometry. How can we find that? This is a beautiful question. 2 moles of what? Of what? Of H2. Reacting with O2, right? Find the mole of oxygen gas reacting with this. Are we together? How are we going to find that? That's we need to employ this what? Mole ratio. How? Just do. What and what are we? What are the 2 molecules that we need here? Or 2 elements? Oxygen gas, hydrogen gas, and what? Oxygen gas. You relate them together. How do you relate them together? But without finding this mole ratio, can you relate it together? No. Since we have known the mole ratio of this to be 2, right? Of this to be what? 1. Of this to be what? 4. Now, what and what are we going to be relating? Are we talking on this product based on the question? No. We are only talking on the what? Reactant. All you need to do, this something that you are given, which is what? 2.0 mole of what? Where is hydrogen gas? This is hydrogen gas. Are we together? Now, you write what? On top, you write what? 2.0 mole. That is the scope there. Now, are we given any moles here? Are we given? That's what we have to find, isn't it? You put what here? You put S mole or Y mole, anyone, right? What is the mole ratio of this one? 2. What of this one? 1, isn't it? You match them together, then you get your answer. How do I match that together? Just say 2.0 divide by, this is what? 2. Are we together? Are we together? Equals to, this is S. Divide by what? What is this? 1, right? Then make S the subject of the formula. Are we together? It will now be what? S times 2. It will give us what? 2S. This times this will give us what? 2.0. Are we? Divide 2 by 2. Divide this by 2. This and this settle one another. This divide by this will give us what? Will give us 1. 1.0 what? What will be the silent? 1.0 moles. That means 1.0 moles will react with what? 2.0 moles. To give us what? 2 moles of what? Water. If you are now getting this, that how many numbers of moles will react with this to get this? We call it what? Stoichiometry. Are we in together? I think I've explained more. Am I communicating? Now, mole ratio. I've explained what? Mole ratio. Let's try and note that. The next thing on this mole ratio is that, let me bring one formula. If you don't want to use this step, you can still use another formula. If you don't want to follow this step, there is still another what? Another ways. Are we together? What is that ways? If you can just cram that. If you don't want to, maybe this is too stressful. In order to find mole, where essence of this is to find moles of what? Moles of oxygen that is reacting with this. When you are doing that, you are doing what we know as stoichiometry. Another method, you can use a formula. he has a formula that we can actually use. What is that? We will just say, just cram that formula. Moles are moles of what? Mole of a given of a what? Of a given element or substance. Anyhow, of a given element or substance. Are we together? Multiply by coefficient. What do I say? Coefficient. Coefficient of a given element, right? Multiply by what? Coefficient of a what? Of a desired. Of a what? Of a desired. All upon what? Coefficient. Coefficient of a what? Of a given. Right? Are we together? Equals to what? Mole of desire. That is the formula. It's very simple too. Mole of a given element multiplied by coefficient of a what? Desire. All upon coefficient of a what? Given equals to mole of a what? Desire. I will tell you what is that. What is even desired here? Then what are the givens here? What are we given? Based on the first question, what are we given? We are given what? That of H2, the mole of H2, right? Which is what? 2.0. That 2.0 mole. The SI unit for mole is what? For numbers of mole is mole. Are we together? Now we are given 2.0 moles, right? This now is whenever I'm seeing mole of a given, mole of a given. What do we mean by mole of a given? What the most that we are given in that question, not the one that we asked to solve. The one that we asked to solve is moles of desire that we want to solve. The one that we are given is moles of what? Given element or substance. It may be element like this, or it may be sodium chloride, sodium hydroxide substance. It may be, we can make it moles of a given substance. Are we? Of a compound, anyhow you want to. Multiply by coefficient of a desire. What is that coefficient of a desire? Is the balance of what we balanced there earlier, which is what? We have 2H2O, isn't it? What? This is 2. What is this? This is 1. All right. Now, where is our coefficient of desired? Here, 1. Are we together? Where is our coefficient of a given? Here, 2. Because it is 2 moles of hydrogen gas. So the coefficient is what? Coefficient of given is 2. The moles of given is 2.0. The coefficient of desire is 1. The moles of desire, that is what we have to calculate. That is another way. What would that be? Just do like this. What are we? Moles of a given. Let's be substituting. What is the moles of a given? 2. You will just say 2.0 times. What is the coefficient of a desire? Are we 1? Divide by division sign, right? What is the coefficient of a given? 2. Are we in together? All give what? Most of a what? Desire. 2 times 1, 2. Divide by 2, 1. Are we? Is it not the same step? So just cram this. Most of a given times coefficient of desire, all upon coefficient of given equals to most of what? Most of desire. It's also ways of calculating what? Stoichiometry what? Analysis. Are we together? It's also what? Under what? This is one of another aspect where we calculate what? We calculate each parameters like mass, like the following. Under what? Mole ratio. Under the relationship between the mole ratio, the reacting mass, and all this wala. That is that under that. Am I in together? Are we in together? That is that under that. Now, since we are getting what is mole ratio, let's try let's bring some questions related to this formula and many questions regarding this by using this formula or another method. And another thing I want to tell you here is that we can actually get another mole ratio here using this formula. What is this? This is 2, right? 2, which is the coefficient of what? Mole ratio, isn't it? 2, what is this? 1. 2 divided by 1. Are we together? Which is for what? H what? H2, right? O what? O what? O2. Are we together? What of this? This is 1. Are we together? O2. You will bring this. You will put it under. Are we together? Divide by what now? 2. What? H2O. Are we in? Equals to. Still bring this. What is that? 2H2O. Divide by. Use it on this. It will be what? 1O2. This is also an aspect. Whereas it's still the same thing. This divide by this. This divide by this. When you relate them together, you get your mole ratio as well. Are we together? Are we really doing something? Now let's quickly see that. That means all this now will be 2 divided by 1. This will be what? 1 divided by 2. This will be what now? 2 divided by what? By 1. Are we together? That is another aspect. Now let's write one question in backing this. We have been talking on the theoretical part. Let's see calculations for those preparing for exams. Why? This is a question from stoichiometry what? Analysis. How many moles of what? Oxygen gas, oxygen molecules react with what? What is it reacting with? With what? Hydrogen gas. Are we together? That means when O is reacting with what? H. O2 reacting with what? H2. In the below chemical reaction. How many mole? What are we asked to do? What are we asked to solve that? Mole. Are we? The first step. How to solve that is by using what? Mole ratio. How to get the moles of this particular question is by using what? Mole ratio. So the essence is the mole ratio help us to get the what? The numbers of mole of one element that we have to find reacting with another what? Another numbers of mole of a given element. So now the essence of mole ratio now is to find what? That's one way of finding mole. That is all. The essence of mole ratio is to find what? Mole. By using what we stated, the first formula, moles of the what? Given, multiplied by the coefficient of what? Of the what? Desired. All upon what? Coefficient of the what? Given equals to moles of. Just apply the formulas, then you get your answer. How with that? Or do it the way with the first one. How with that? Let's quickly do that in the first way. What is this? The first thing to do is we have to find, what are we finding? This one. Are we together? What are we given? We are given, what is this? 1.6 mole of what? Hydrogen. This is mole of a given. This is mole of a desire that we have to find. Are we together? Now, firstly, before we can do that, we have to find the coefficient of a given and the coefficient of a what? Desire. We already they have balanced this. Note that in your exam, they might not likely balance it. You have to be the one to balance. But yet, they have helped us out. They have balanced this. What is the coefficient of a given here? 2. Now, we are, see, 1.6 moles of this. We are given what? 1.6 moles of this. Are we together? Which is the moles of a given. Then the coefficient is what? 2. Now, this is how many mole of oxygen molecule. That is moles of what? Desire. Are we given moles of desire? That's what we have to calculate. Where is the coefficient of desire? 1. Are we together? Now, here it is the water. We don't even have to solve this one because we didn't. In the question doesn't relate to this one. We are just going to be dealing with the what? Just the 2 reactants. Are we together? Assuming if the question said it included water here and there is exclude of 1 or 2 this, then you will relate it with. Are we together? With water. Am I communicating? Now what follows? What will that be? Now, where is the moles of given? Which is 1.6. And this is the given. All you need to do, just write it on top. Or you write it like this. 1.6. Are we? Divide by, what is the coefficient of that given? 2. Very simple. Equals to. Right. Do we know the moles of a desired? No. Which is what? S or Y? Put Y here. Or X. Or G. Anyhow you want to. Divide by, what is the coefficient of a given? 1. Divide by 1. Then you get your answer. What would that be? Cross multiply. 2 is facing here. 2 times y will give us what? 2y. 1. I drew this something. This sign is for you to know where 1 is facing. This is where 1 is facing. Where 2 is facing, this is this. But to those writing y, this is not applicable. You have to write it cross multiply. You don't do like this. But for the easier ways to get it quick, 1 is facing 1.6, 2 is facing what? Y. That is why I drew this line. All you need to do, normal standard form, you put what? Cross multiply. Are we in? Now 1 times 1.6 times 1, 1.6, 2y, right? Yes. Now what are we solving for y? Divide through. What is the coefficient of y here? 2. Divide 2 by what? 2 by 2. This settles this. Y now, y equals to 1.6 divided by 2. Someone to press that. 1.6 divided by 2 will give us what?
0.
Is 0 point what? 8. Is 0.8 moles. You put it because it is moles that we have to get. That is the SI unit. Is 0 point what? 8 moles. That is just the answer there. Or you use the formula that I told you about, which that will be on the comment section. You to try that by using the moles of a what? Of a what? Of a given. Multiply by the coefficient of a what? Desired. Divide by the coefficient of a what? Given. Equals to moles of the what? Desired. You can do that. That is an assignment for you as well. Now let's go to another question. Question number 2 on what? Stoichiometry. What should come to your mind is that read the question, then digest what? The question. How many mole? That means what are we asked to calculate? Mole again. Mole of what? Oxygen. Are we together? Will be needed. That means how many moles of oxygen will be needed to what? React completely with what this. That means what are the two things that is reacting? Ammonia. NH3 is ammonia. NH4 is what? Ammonium. NH3, when it's reacting with this, how many moles of this will be reacting with this? That's what the question is asking. And already we are given moles of what? Ammonia to be what? Is 0.5 what? 0. That means we don't know this mole. This is what we have to calculate. But we can't calculate this without the what? This chemical reaction. Already they have helped us to balance this. If they didn't help us to balance this, you have to balance it by yourself. And I know you know how to balance that up. Are we in together? What is that? The first one we do is almost the same thing related to this. You can use the formula. Which says what? Or you do it the way we are doing it. Are we together? What is that formula? Mole what? Mole of a what? Multiply by what? Coefficient of a what? Of D. All upon C what? C given. All equals to M what? MD. Are we together? Most of given. Coefficient of desired. Coefficient of given equals to most of desired. Are we together? Now what follows? What now let's see. We have to know our coefficient of this chemical reaction, right? But what are we? Do we really need this product side or this reactant side? Right? We need the what? The reactant side. You are with me. Now what are the reactant side? What is the coefficient of ammonia? 4. What is the coefficient of oxygen? 3. That means it is these two things that we need. Forget about this one. Don't forget to what? Like, comment, and what? Subscribe. Are we together? And also share to the needies. Right? This will now be what? 4 and what? 3. Are we together? That means CD now will be what? Where is our CD? What are we looking for? Oxygen. Which is our CD? Coefficient of the what? Of the desire. Which is what are we having there? 3. We'll put 3 here. What of C given? Coefficient of a given is what? What are we given? We are given this. Which will be what? 4. Multiply by what is this one? Is 0.5. Which I'm going to substitute in here. Are we in together? Now what would that be? Therefore, that one will be what? It will be most of a given. What is that? Is 0. What? Is 0.5. Multiply by, you don't call it 50. Is 0.50 as a science student. Multiply by what is CD? CD is what? 3, right? Divide by what is CG? 4. Which is what? 4, right? Yes. All equals to MD. Now, someone should press the calculator. Is 0.50 multiplied by 3. You put 1 here. Because we have numerator, denominator. You make it numerator and denominator, right? 0.50 multiplied by 3. What is it bringing?
1.5.
When you multiply 0.50 by 3, is giving what?
1.5.
1.5. Therefore, 1.5 divided by what? 1 times 4 will give us what? 4, right? Are we in? 1 times 4 will give us what? 4. Then we have what? Most of the what? Of the desire. 1.5 divided by 4 will give you what? Please press your calculator.
0.375.
it will now be MD now will be what? Is 0.377 Then what will be our SI unit? Since it is mole, the SI unit will also be what? Mole. Are we together? That is all the answer. Are we in? Now let's see another question. I will urge you in the comment section. Let's make this your own assignment. Is make this. Let's put 60 here. Put 60 here and do the way we follow this. Do it the same way. You are still going to get it. That is an assignment for you. Let's go to another question. If I react 4.8 moles of hydrogen gas with excess what? Nitrogen what? Gas. How many moles of ammonia molecule will be formed? What is that? Meaning when we react what? This H2 with what? With what? N2. How many molecules of this will be formed? What is that? That means we have the product. Now in this our example, product is what? It implies, right? Meaning we have our product with what? We pick one of this and this. What is that we are going to pick? Check what we are given. What with that? Hydrogen. That means I'm going to be reacting hydrogen with what? With this. So I will match this now with this. This now is for hydrogen. Then I will match it with this one. That's what we are going to. What is that? That means I'm going to be. Let's bring the coefficient down. What are we having here? 2. What of this one? We have 2. Are we in together? What is the moles given here? 4.8 of hydrogen, isn't it? Now 4.8 moles of hydrogen. You can write it that since we have that solution for that, it will be 4.8 divided by what? What is that? Divided by 3 equals to what are we having here? 2, which is S unknown. What is it that we're having on the ground? 2. I know we have explained this in our previous video on this. This will now be what? Cross multiply to get this value of S. What would that be? S equals to what? This is facing this one. This is facing this. S times this will give us 3S. This times this will give us what? 9.6. Are we in together? Now, what are we going to do to get this one? Divide through by the coefficient that this S is having. What is that? 3 divided by 3. Are we into that? This is this, settles this. What are we left with? 9.6 divided by 3. 3.2. What will be the SI unit now? It will be moles. Because we have to know. That means when this is reacting with excessive what? Nitrogen gas. The moles of ammonia that will be produced is this 3.2 mole. That is just the question regarding that. Aspects for those preparing for exams and as a chemistry student, that's one aspect in solving what is stoichiometry what calculation. There's still one aspect, or let me say part 2 of this stoichiometry analysis. Whereas I told you